Hi guys, welcome to this session by K21 Academy. In this session, we'll be seeing how we can use Machine Learning Studio from Microsoft Azure. So without any further ado, let me quickly walk you through today's agenda. We'll start this session by understanding machine learning in general and what are the various types of algorithms that are involved in it. Moving further, we'll have a look into Machine Learning Platform by Microsoft Azure. Finally, we'll end this session by discussing various reasons for you to learn Microsoft Azure's Machine Learning Studio, followed by a demo where we'll be predicting vehicle prices. Alright guys, so without any further ado, let's get started with general discussion about machine learning. So the first question that we usually have over here in our mind is what exactly is machine learning, right? It's a branch of artificial intelligence based on the idea that system can learn from data, identify pattern, and make decision with minimum human intervention. So what I'm trying to say here guys is that you can provide huge amount of data to our machines, and machine learning algorithms are capable of identifying different patterns, and based on the pattern they create a model. And this model is basically a generalized version of what a human being would predict. So now that we know what is machine learning, now you might be wondering, why do we need machine learning in our day-to-day life? Well, most of you might be wondering, right? Like, when machine learning is all about decision making, why don't I just use condition statement? Well, you see, condition statements are computationally very expensive, and this condition statement works well when you have a very less amount of data. But what would you do when you have lakhs and crores of data at one time? It would be impossible for you to write if and else statement for every parameter there is. This is where machine learning comes into picture. Machine learning learns from prehistoric data, or whatever the data that is being used for training, and it creates a generalized model. And based on this model, whatever the new data is there, the output is being predicted over here. Okay, so now that we know why and what exactly is machine learning, let's now see some of its application. You see, machine learning is being used in every aspect of our daily life. This can range from something as simple as unlocking your phone to something a complicated task such as landing a rover in the Mars. So let us now discuss some of the popular applications of machine learning. So starting off with image recognition. Image recognition or image processing is a method of performing some operations on an image. This is done in order to enhance an image to extract some meaningful information which is perceived by human eye. Image processing or image recognition is one of the early applications of machine learning. Some of the places where image processing is being implemented is on automated cars, healthcare sector, army, and many other places. Moving on to the next one, we have recommendation engines. If you know, right, like if you're trying to search something on Amazon, the products that you get or the ads that you get is something similar to what you have searched before. And this is similarly applied on your Netflix recommendation or Amazon Prime or many other multimedia platforms. Recommendation engines are of various types, and based on your application type, we can develop such kind of systems. All right, so next we have spam filters. Well, if you ever wondered, right, like how emails or whatever the messages that you're getting on your inbox is being categorized into spam or not spam, this is all thanks to machine learning. So what's happening over here? Well, in order for you to deal with text, we'll use NLTK or NLP platform, and based on the classification task, right, like based on the previous data, like if there is a group of emails where there are certain characteristics, let's say 100% or free or something which looks too good to be true, will be classified as a spam, and rest are not a spam. This is pretty helpful as this becomes the first stage, or let's first line of defense for you to save against the intruders. Next, coming down to speech processing. Alexa, Google, Apple, Siri, and all of these are nothing but applications of speech processing. But this is not just it. Speech processing is also used in forensic in order to categorize or differentiate or to find any abnormalities in the sound. So speech processing is something which we have come ahead over the span of time. Moving on to the next one, we have automated language translation. If I've ever wondered how languages are being translated from one language to the other, it's not by using some dictionary or some pre-trained if-else condition. As we all know, textual data is a sequential data, which means the single word, which is actually a filter, is totally dependent upon the previous word. So this is called as sequential data. And in order to deal with sequential data, we have many deep learning algorithms such as recurrent neural network, LSTM, GRUs, and many more. We all know that Google Translator are pretty advanced, as we can translate from one language to multiple languages at the same time. So these were some of the applications of machine learning and why the motivation that you should learn. So moving on to the next one, there are basic categories or types of machine learning algorithms. So starting off with supervised machine learning algorithms. Supervised machine learning algorithm is a class of machine learning algorithm where the output values or output variables have been predefined. Let's say, if I'm trying to perform multi-class classification or a two-class classification, which is also referred to as binary classification, where the task is to classify whether the given feature is of a cat or a dog. Over here, we know the output can either be a cat or a dog. Okay, so this is what is called supervised machine learning. So this cat or a dog, right, the output feature, this is called as dependent features. And in supervised machine learning algorithm, both independent features and the dependent features are given. And some of the two common tasks that is usually performed using supervised learning algorithm is, regression task and a classification task. Regression task usually deals with numerical data, and a classification task usually deals with categorical data. So moving on to the next type, we have unsupervised machine learning algorithms. Well, you can say unsupervised machine learning algorithms is a type of machine learning algorithm where the output values, right, or the independent values are not there. So what happens over here is machine learning algorithm will try to cluster the values, so whichever features have the similar characteristics, it groups them into one, and they are classified into, which class do they belong to. Moving on to the next one, we have semi-supervised learning. This is the combination of supervised learning and unsupervised learning machine learning algorithms. The major advantage, or let's say the major application where this is being used is, in EDA. The next type we have semi-supervised learning. Semi-supervised learning is a combination of supervised machine learning algorithm and unsupervised machine learning algorithm. So what happens over here is, some of the characteristics or some of the data that is being missing, right? Let's say when you're trying to perform EDA or some other task where you're trying to find the missing value, you can use unsupervised learning to find them. Also, you can also perform supervised learning to train the data, and then perform the normal task as it goes. But in short, semi-supervised learning is a combination of supervised and an unsupervised learning algorithms. Finally, coming down to Q learning or reinforcement learning. Reinforcement learning basically makes use of an agent. So over here, the machine learns on itself. This is something similar to how a baby learns to walk. So here machine learning algorithm makes use of an agent. If a machine learning algorithm tries to do something positive, he has been rewarded with something nice or something positive. And if it tries to fail, and there are some penalties that goes in behind it. All right, so now that we know what exactly is machine learning, what are the various applications, I'm pretty sure now you might be motivated to learn, or you might be motivated to implement machine learning algorithm. So before we move ahead to understand Azure Machine Learning, let me quickly tell you what exactly is Microsoft Azure. Well, you see, Azure is a public cloud computing platform which provides solution for something like infrastructure as a service, platform as a service, software as a service that can be used for services such as analytics, virtual computing, storage, networking, and much more. This cloud computing service created by Microsoft is used for building, testing, deploying, and managing application and services through Microsoft Management Data Centers. So the one such platform over here is nothing but Azure Machine Learning. Well, you see, Azure Machine Learning can be used for any kind of machine learning task, which can range from classical machine learning to deep learning, something from supervised to unsupervised learning. Whether you prefer to write Python or R code in this SDK, or you prefer to go with something like no code and less code options in the studio, you can build, train, track machine learning and deep learning algorithms with Azure Machine Learning Workspace. Before we move on to our hands-on demo, you might be wondering what is the reason or what are the advantages of learning machine learning Azure platform, right? So let me give you a couple of reasons why you should consider learning this. So first off, over here we have machine learning as a service. Well, you see, Microsoft Azure offers machine learning algorithm as pay-as-you-go service. Using Azure Machine Learning, the businesses are not required to set up complex or purchase any big hardware or software. All they need to do is purchase the service, and they can start developing and deploying the machine learning applications immediately. Then we have flexibility and easy to build interface. Over here, all you need to do is drag and drop the various algorithms or various parameters that goes in. Okay, with this it makes it nearly easy for anyone to to develop and deploy the machine learning algorithms. Unlike conventional type where people usually tend to write the code on a Jupyter notebook, here everything is drag and drop. Next, we have wide range of supported algorithms. You see, Azure Machine Learning offers readily available, well-known algorithms that can be configured simple by drag and drop. It not only requires the knowledge of data science and expertise in the algorithm, all you need to do is which algorithm to apply at what particular time. Moving on to the next one, we have greater documentation for machine learning solutions. We all know that Microsoft is a very huge company and it has a very big reputation over here. So Every algorithm and every step that you want is well documented with tutorials, references, and a lot of examples to work with. This makes it easier for you to build, manage, deploy machine learning solutions across the platform. So these are a couple of reasons why you should consider learning Azure Machine Learning. So now that we know what we are working with, let me now quickly jump to this Azure Machine Learning Studio and show you how we can, predict vehicle prices. Alright guys, so this is how the Microsoft Machine Learning Studio would look like. Okay, so we have projects, experiment, web services, data sets. Let me quickly show you what this data sets over here would look like. So here you can, add up new data set, you can upload any new data sets, and we have a lot of sample data sets over here, something that range from MNIST, and we have a lot of it, right? And over here, my data set, this is where you upload a custom data set for yourself. Then we have trained models. You can have pre-trained models. You can also, there are free pre-trained models over here, or you can also train your model and upload it over here. And finally, coming down to experiments and then projects. Okay, so over here we have this demo project, but now, as I mentioned earlier, we are going to work on a project where we are going to predict the vehicle prices, right? So let me show you from the scratch what happens. So first off, all you need to do is click on new over here, which is present on the bottom left corner, and then you have to click on empty project. So before that, just go for experiment, and you can also take blank experiment. Okay, so this is a better option. Just take up a blank experiment, and this would give you this particular interface over here. So this is where the data sets are present, and you can add up multiple libraries and all that. You can do some experimentation over here. First off, let's give the name for our project over here. Let's say vehicle price prediction. Okay, so we have this, and you can give some summary and description. This is totally up to you, and it's your choice. So let me give you let me give a mini map. Let me minimize this. Let me expand this completely. Okay, so first off, what we're going to do is, if you're someone who has already have an experience, you know that we are going to import the data set, right? So first off, let's see what are the data set we have. So save data set, and these are the samples over here. The data set that I need over here is for the vehicle prices. So let me check out if I have that. Okay, so let's see where our vehicle prices is, and if I scroll up, yeah, so as you can see here, we have automobile price data, right? So let me drag and drop. All I need to do is drag and drop. Okay, so this is all there is. You can drag this anywhere, you can zoom in, zoom out, it's totally up to you. If you want a mind map, you totally have it over here. Okay, let's minimize this for now, and let me minimize this here as well. Okay, and now, so this is the data. Let's say you want to visualize this. All you need to do is give on a right click, and then you can visualize it over here. So visualize. So as you can see, we have a couple of features. We have symboling, then we have make, that is the type, then fuel type, then we have aspiration, that is naturally aspirated or standard, number of doors, body style, driver wheels, that is rear wheel drive, four wheel drives or forward wheel drive, then engine location, wheelbase, and we have various other parameters. And finally, this is our dependent parameter over here, price. All of these parameters here are independent parameters. So in the next stage, what we're going to do is we are going to select our columns, right? So let me quickly show you what are the things we have here. If you have data format conventions, right? Let's say you want to convert this from CSV to some other file, like various other values you want. So you can do that over here, then transformation and all of this. So what we'll do is we have this box here called as select columns. Select columns. That is this one, and let me paste it over here. So this is just like building Lego blocks, and let me connect this from here to here, and this is done. So let me give a right click here, Okay, so as you can see here, we have launch column selector, right? So click on this over here, and these are the various columns that we have, right? So what we'll do now, we have to select the columns that we need. So let's see what and all columns we have. Okay, but before that, let me come down here. Let me visualize what's happening here. Let me visualize. Let's see which columns have the most missing data, and which one can we use. So as you can see here, we have this one. We can see that a lot of data is missing. So missing values over here is 41. Okay, so let me ignore this. Okay, I will be having symboling. This is fine. Then we have maker. There's 0 missing values. Fuel type, aspiration, number of doors. Okay, here we have just 2. It's fine if it's 2. It's fine. It's no big deal. Body type. Let's see. Let's go through all the data set over here. All right, guys. So except for one, right? That is this one, normalized losses. Everything, very few database are missing. So what we'll do now is we'll try to, excluding that, we'll have all the values. So let me have launch column selector. I don't want normalized data, right? So I'll have this. Okay, add it over here. And we'll add all of this over here. Okay, so as you can see, except for one, I have added all. And let me now check this, which means these are the columns that I've selected. And finally, what we'll do now is, as I've mentioned, few of the data were missing, right? So let's work with that as well. So for that, we have this block called as clean missing data. Okay, so I'll drag this and paste it over here. As simple as that. Now I need to connect this from here to here. And if I click on this, you will see we have certain values, right? You want to whichever data is there, do you want to replace that with what kind of values? So replace it with mean, median, mode, or just delete it. So what I'm going to do is I'll just replace this with a mean value. Or you can also remove it, right? It's totally up to you. So I hit this launch, I do it for all columns, and yes, hit. So now finally what we're going to do now, we are going to also take this column selector again. So all right, so now what we're going to do is, from this cleaning data set, right, or from this cleaning box over here, I'm going to take select columns. I'm not going to take all the columns. Let's take few of them. So for this, I have select columns in data sets, drag and drop, connect it from here to here. Okay, and let's see which are the columns that I need. Let's take column selector, include column names. Okay, so let's see which and all columns that I need. Okay, let's take fuel type because that's pretty important. Like in generic sense, we need the maker, and then fuel type is okay. Fuel type we have already added over here, and then number of doors plays an important role. We can take aspiration, body style. Yes, sometimes when I try to buy a car, wheelbase matters a lot, and drive wheel also is important. And then finally, we can also take engine type. Fuel system is important. And horsepower, yes, we can definitely consider horsepower. And then price is obviously important because that's what we are trying to predict over here. And we'll click yes. And now what we'll do is, let me quickly scroll this up. So what we're going to do now is for this select column in data set, we are going to split the data, that is into train, test, and split. So for this we have split data. Okay, so this would let me drag and drop here, and let me connect this from here to here. Okay, and if I click on this, you can see a random seed. You can give let's say 47. Okay, by what fraction do you want to split? I'm going to give here as something like 20%, that is 0.20. All right, and now finally this would be for the test, and this one over here will be for the train. Okay, so let's now quickly get that done. So the model that I'm going to use here, now we can use linear regression, any other classification algorithm you want. Let's say something like linear regression. Okay, so we have linear regression. I'm going to drag and drop over here, and let me give a correct alignment to this. Okay, now for this linear regression model, we have to train a model. So for this, we have another block called as train model. So we'll take this and we'll pass it down over here. And now all we need to do is connect it from here to here, and collect linear regression from here to here. And finally, for this train model, we'll have something like, let's say score, right? So let me also get that sorted out, because I want to see how well my model is performing. So we have score model. Let me drag and drop this, add over here, and we will see the score with also respect to the test values. Okay, so let me get this sorted done. Drag this from here to here, and drag this from here to here. And finally, I want to evaluate my model. So evaluate. Let me add this. Okay, and let me connect this from here, score model to evaluate model. So once you're done with all of this, right? So let me zoom out over here so that you can have a better picture. So as you can see here, we have, first off, we got the data, that is the automobile data, and then we selected the column. Then we deal with the missing data, that is performing, the feature engineering, feature selection. We selected the columns, we split the data between test and train. Then we called the linear regression model, we trained the model, and then we saw the score and evaluate the model. So once you're done with this, make sure you save it. And then in the next stage, you're supposed to run your model. So this, give it some time, like a minute or so. Okay, so as you can see, we are done saving our model, but there's one last step that we're supposed to do, that is over here. So we'll click on over here, and we have to say evaluation parameter, right? So let me fix this. Alright guys, so before you run this over here, make sure you add the column, that is which column you want to add. So once you left click over here, you can see launch column selector, and then over here you have to select price, because this is our dependent feature, and this is what we are trying to predict. So once we are done with this, let's also get our evaluation model over here. And we'll just call this to this part, and finally connect this over here. Okay, and now finally we are going to save this, give this, as I mentioned earlier, give some time for this. And once this is done, we are going to run our application. Okay, so now let's see what's happening, right? So let me show you where exactly this model is getting run. So as you can see here, we have multiple tick marks, right? So we have a clock and then we have tick marks. So this means, our model is running over here. So we have found some error that is missing data, right? So let's see where we are going wrong. Alright guys, so now that we know what exactly are we working with, let me now quickly jump to our Azure Machine Learning platform and show you how we can, build a model which can predict the vehicle prices. So let me quickly move to my screen. Alright, so as you can see over here, this is how the interface of Azure Machine Learning Studio would look like. Okay, so over here you have projects, and this is where you create your experiments. You have various web services. You can take various types of data sets. You can even upload your data sets. Then we have trained models and the settings. So first off, we are supposed to create a model, right? So what we're going to do here is we're going to go for new. Then we come down for experiments, and here blank experiment. As simple as that. Okay, so once we are presented with this screen, this is the title of the experiment that you want to give. You can just give whatever you need. Let's say vehicle prices. Okay, so we have this vehicle price prediction, and now you can add some summary description. It's totally up to you, it's your choice. So coming down to the first step, if you're someone who has already worked with machine learning projects, the first step that we have is to import the data. So good thing for us, all the data sets are present over here. Like if I go here for save data set and then samples, you can get a lot of suggestions over here, like movie tweets, movie ratings. And the one that we need today is for this one, automobile price detection. So let me quickly drag and drop over here. So this is as simple as that. We don't have to write, import CSV or import any libraries. It's just drag and drop over here. And now if you're someone who is curious to know what's happening inside this or what's present here, just come down to one and then click on visualize. Give it some time. Okay, so these are the various features that we have. As I mentioned earlier, each of these columns, they are nothing but independent features. And the dependent feature or the output that we are looking for is the price. Okay, and now if you take a look, right, if we try to perform some ED over here, you can see, we are getting this brief value over here. Number of missing data is 0, which is fine. Then we have normalized losses. Oh, okay, there's huge amount of missing data here. And then even this, we don't have much of missing data. And then all of these are different features. Okay, and all of these are independent features I've mentioned earlier, and all of these features contribute towards the price of a particular vehicle. All right, so now what we're going to do is let's try to exclude this particular row, right? Normalized losses. So in order for me to do that, we have to import another box kind of stuff here, or let's say tab. We call that as select columns in dataset. So that is select columns in dataset. It's this one over here. We drag and drop this over here. Okay, so now we take this and drag a line. Okay, and now we're supposed to select a column. If you click on this here, you get this launch column selector, and here you have all types. Okay, and then what we need to do is, what are the various columns that you want. Okay, so now except this normalized losses, I want all the columns, right? So what I'll do, I'll select symbols, and then let me select all of this over here. And then if you want to add this to the selected columns, all you need to do is just pass it over here. Make sure you select all of these. And it's very important that you also select the price. Okay, so let me just get this done faster. All right. So now what we need to do is just transfer all of this to the selected column by hitting on this. So except for the normalized loss, we have selected all. And now all we need to do is just check over here. Okay. So we have selected the columns, and you can see the various column names that we have selected over here. All right. So in the next stage, what we are going to do is, if you remember here, if I click here, visualize, some of the columns had missing data, right? Like let's say one or two values or one or two records were missing. Like let's say, let me show you that. So here we don't have any missing data, but here, as you can see, right, for this feature, number of doors, we have two missing values. So what I'm going to do is, missing data, handling the missing data is pretty important. So what we'll do is we'll have this tab again called as clean missing data. Okay, we drag this and drop it out over here, and we will add this here. And now when I click on this, it'll give me various options. Okay, and what you want to do, like this is the minimum value, maximum missing value that you have, and what kind of cleaning mode you want. Like you want to have like replace with mean, median mode, or remove the entire column. As we have very few numbers, right, of missing data, I'll just remove the entire row. Okay, not the column. Please make sure you don't remove the entire column. That means we are removing the feature. So we'll remove the entire row, and that should be it. And now finally we'll have another column selector. So it says select column from dataset. We'll drag it, and we'll take the first part from here to and connect it down here. And now we are supposed to select some columns. So make sure whatever columns that you have selected, right, it's important. Okay, let me show you what I'm trying to say. So here we'll have include and the name of the columns. Okay, so let's say you're trying to buy a car, right? What are the important, or what are the various factors that you kind of look into? So first off, you'll look into, fuel type, whether it's a gas or, whether it's a petrol or a diesel, whatever it is. And then we have what kind of company it is, like the make. And then we'll also take something like aspiration. Is it naturally aspirated or what? And then let's say body style, number of doors, because usually two doors are like considered to be sports car, engine location, front or rear, and then we have body style. Moving ahead, we have wheelbase. Okay, so we'll ignore that. And then we have, let's say, engine type. It's important that you have price. This is pretty important. And then we'll also take horsepower. And then moving ahead, we can take compression ratio. All of these, I would say that, do some experiments over here, and let us know in the comment box below what is the accuracy that you're getting. And let's take a couple more. Peak RPM, city mileage, let's take length, and finally let's take one last one. Let's say strokes. Okay, so these are the number of columns that we are including, and let's hit enter. All right, so this looks great. Now that we are done with this, in our next task, we are supposed to split our data set. We're going to split our data set between test and train data. So this would help us in understanding what's happening there. So for that, we have split data. Okay, this is the tab that I'm going to have, and we will just drag and drop this. And when I click here, you will see by what fraction you want our row to be, to have a split, right? So we have row split. So, if I give here for 5, like 0.5, that means 50% goes for the test, 50% goes for the train. I don't want that. What I'll do is I'll go for, 0.8, which means 80% goes for the training and the rest of it goes for the testing of the data. All right. So now that we are done with this, we are supposed to train a model. Okay. To train a model, as we all know, if I scroll this a bit up, our output variable, let me show you that what I mean to say. Okay, so these are the features, and our output variable over here is a price, right? So which is a numerical value. But if you want me to be specific, it's a continuous value that we have. So in order to deal with the continuous value, what I'm going to do is I'm going to use regression task. Okay, so this is basically a regression task, and we'll have simple regression over here. So for this, let me call linear regression, or you can also say multiple linear regression, or let's just take as regression over here. Okay, so if I scroll down a bit here, and we can take linear regression here, keep linear regression part over here, and then we have another model over here called as train model. So let me get that as well, and I'll drag and drop this over here. Fine, and now all we need to do is connect this from here to here, and this is the part wherein we have it for the training data set, and we are going to train our model. To train a model, it's important that you select which is our output or dependent feature. So for this, you have column selector, and all you need to do over here is the price. Okay, and this price over here is going to be our output feature. And finally, what we'll do is let's also add some model for analyzing the score. So we have score model, which I'm going to add over here, and another part I'll give here is from here. And finally, we'll also have some evaluation mode. So let me get that evaluation model. All right, so let's quickly connect this, and this is all there is. Okay, so now what's going to happen now is, let me give you a quick recap of what we have done. First off, we loaded our data, then we tried to see which column we want, basically feature engineering or feature selection. Then we handled the missing data. Then we decided which are the finally we decided which are the columns that I would use for training my model. Then we split our data just for evaluation of a model. The model that we're going to use is linear regression. Then we train a model over here. Then we want to see the score, like what's happening, score model, and finally some evaluation parameter. So once that's done, make sure you save this. This takes quite some time, and then the next task that you have is to run all. So as you can see here, we are getting this clocks icon. So that means some action is going to happen, and once the action is done, it gives you this tick mark. So let's wait for some time and let's see what happens here. All right, guys, so as you can see, everything is a tick over here, and which means that our model has successfully ran. Let's quickly see what are the things that we can get from here. Okay, so over here you'll get output logs, but let's also see what happens. You can visualize the evaluation model. So this would basically give you, the errors and all of that: mean absolute error, root mean square error, and then relative absolute error, and the coefficient of determination. Apart from this, you also have this. This is where we can, a layman can understand score model. So let's see how well our model has performed. So these are the various features that it had taken, and this is the price which it is supposed to be, right? So this is the price it has predicted, and this is the price it is supposed to be. As you can see here, our prices are almost similar, like they're almost neck to neck, but there's a slight difference over here. And the reason for this is because we have to perform more feature engineering, and as we are trying to use logistic regression, it's important that your data is linearly separable. Okay, let me show you what I mean by that. So when you're trying to apply logistic regression, right, it's important that your data is normally distributed. Okay, so this is one of the reasons why we are getting quite a less number of accuracy. What I would like you guys to do is choose various types of model. Like over here we have just used regression, all right. So what I want you to do is take on decision tree or various other machine learning algorithms and see what accuracy you're getting. And if you're someone who's getting really good accuracy, please do mention them in a comment box below. All right, guys, if you're someone who's looking forward to understand how we can use Microsoft Azure for data science application and its certification, I would definitely recommend you to check out our free class at K21Academy/DP10002. Okay, so with this, we come to the end of this session. Until next time, goodbye and take care.